Pills are defined as small balls of entangled fibers that are attached on the surface of a fabric or material. Pilling resistance is a measurement of the tendency of a material fabric to form pills on its surface. The pilling of textile fabrics is a very complex property because it's affected by many factors, including the type of fiber or blends, fiber dimensions, yarn and fabric construction, fabric finishing treatments, and end use. The development of pills may be accompanied by other surface phenomena such as loss of cover, color change, localized frosting, or the development of fuzz. Pills form both during wear and laundering. Most pills are formed in laundering, where wet and dry abrasion occur from tumbling, and a sufficient supply of loose fiber is available to aid in the formation of pills. Pills are formed when a fabric has surface fiber that can collect other available fibers, which then form a pill. The fiber or fibers that hold the pills to the surface of the fabric are called anchor fibers. Normally, these are very strong fibers that will tend to hold their pills during repeated cleaning cycles. Pills that form during wearing occur under the sleeve arms on shirts and around the collar where men's beards abrade the fabric, and in the crotch area of pants or slacks. This type of pilling is referred to as regular pills, since the fibers that form the anchor as well as the lint come from use. Fibers that come free from a fabric or other fabrics and become attached during laundering are commonly called lint or laundry pills. These can become quite large and noticeable. Pilling and fuzzing are common among fabrics made with spun yarns, where many fiber ends protrude from the surface of the yarn and fabric. Spun yarns of low twist levels will tend to fuzz more in wash and wear. If the spun yarn consists of cotton and a man-made fiber, the tendency to pill is greater than with 100% cotton because the higher strength of the synthetic fiber allows for a better anchor. Typically, 100% cotton fabrics do not pill. Animal fibers such as cashmere and fine wools may pill due to the strength of the fiber. Filament fibers can pill if the individual filaments are subjected to breakage during use, and when filament products are washed in a load of fabrics that can supply short fibers, pilling might occur. The degree of fabric pilling is subjectively evaluated by comparing the tested specimens with visual standards, which may be actual fabrics or photographs of fabrics showing a range of pilling resistance. The observed resistance to pilling is reported based on a scale ranging from 5 to 1, no pilling to very severe pilling. The most commonly used tester for pilling is the random tumble pilling tester. The test method is ASTM D3512, Pilling Resistance and Other Related Surface Changes of Textile Fabrics, Random Tumble Pilling Tester. In this test, a group of 3 specimens are placed into a cylinder in which a spinning rotor or propeller tumbles the fabric for a specified testing time. The inside of the cylinder is lined with a natural cork liner to serve as the main abradant. A small amount of test lint is added to the cylinder. In addition to the lint added, lint may also be generated from the specimens during the test. The action of the propeller works the specimen against the cork liner in a random manner. The high rate of spinning results in numerous strikes on the specimens. If anchor fibers are raised and are too strong to break off, the loose lint will accumulate on the tip of the anchor fiber and form a pill. The test is run for a specified number of minutes, usually 30. The machine is stopped and the specimens are removed. Any loose lint on the surface of the specimens is vacuumed off, and the specimens are rated against the 5-point scale. Also, the cylinders are vacuum cleaned. If another 30 minutes of testing is needed, then new testing lint would be added with the vacuum samples. The pilling specimens are rated on the 5-point scale using ASTM Standard Test Procedure D3512. In most specifications, if the fabric passes, then another 30-minute cycle is run. In this scenario, a final rating is made after the total 60 minutes are run. The Martindale tester used for abrasion resistance can also be used for pilling propensity and other surface changes such as fuzzing and matting. ASTM test method D4970, pilling resistance and other related surface changes of textile fabrics, Martindale tester. The apparatus and the settings used for abrasion are also used for pilling. The difference is that the abradant used for abrasion resistance testing is removed and a matching specimen of the test fabric is used to rub against the test specimen. Any pills formed are rated the same as in the random pill testing method. Fabric restrictions encountered for Martindale abrasion testing are related to pile height and thickness. Some very thick fleece and other pile fabrics do not process well on this tester. Other fabrics that have variable thickness or areas of different pattern heights might also cause inconsistency in the test. Examples of these fabrics are waffle, seersucker, thermal fabrics, and other similar constructions. In this test, specimens of the same fabric are mounted on the Martindale tester in both mounting positions. The top position has a small circular specimen, and the bottom has a large circle of the same fabric. The faces of the test specimens are rubbed against each other in a geometrical pattern. The motion starts as a straight line, which gradually widens in an elliptical pattern, which then becomes another straight line in the opposite direction. This movement repeats over and over during the test. The pressure between the two specimens is considered a light force. The degree of fabric pilling or surface appearance change produced by this action is evaluated by comparison of the tested specimen with visual standards that may be actual fabrics or photographs of fabrics showing a range of pilling resistance. A predetermined number of cycles, normally 100 movements, is run. The action of the samples on a knitted interlock fabric are shown here. The fuzzing of the large bottom specimen is clearly seen. At the end of the movements, the smaller specimen is removed and evaluated. This specimen shows some fuzzing, but no pilling. The method for rating the specimens is spelled out in the test method and is very similar to the rating of the random pilling samples.